Open source rumperdis in the data centers and digital infrastructures. I'm John Laban from the Open Compute Project Foundation, and I'm based in England. So I'm speaking from England. Welcome. Now, what I would like to cover is the impact of this open source technology. And while I'm talking, if you want to search the meaning of the word rumperdis, then please do so, because this open source technology is more disruptive than disruptive. So if you search rumperdis, you will understand what that word means. Now, the BICSI members down in the CALA region, the Caribbean and Latin American region, are going to be impacted by this technology. And we've seen huge disruptions in Europe, North America, in Asia because of this, and it's quite profound, some of these issues that will occur. For example, in an OCP data center, there are no permanent copper cabling links. There are no Cat5e cables, there are no Cat6 cables. Now this is going to cause a big problem for BICSI members in the CALA region, because they probably make a lot of their money installing structured cabling systems. But don't despair. In an OCP data center, an Open Compute Project data center, there is a lot of fiber, which I will cover shortly. Now, just to kick off, you need to prepare for this with some education, and I recommend these books for you. And these books, starting with The Big Switch. Now, The Big Switch by Nicholas Carr on the top left there. After I read that book back in 2008, I sold one of my businesses. I sold my data center design and build business. The argument in the book is that computing will be just like a utility, like electricity. And he takes you through the arguments of computing moving towards a basic commoditized utility in the future in what we call cloud data centers. Another book that you might need to consider is how you break out of the habit of the traditional methods. How do you get out of that? So another book I would recommend is that book, The Power of Habit. When you start to get involved with disruptive technologies, another book that's very, very useful that will help you with the marketing of these technologies, how these disruptive technologies move through a market, is Crossing the Chasm. So anybody that's in the sales area or a business owner, read that book, Crossing the Chasm, because as you develop these technologies in a market, there are better ways to sell that solution, and it's very different depending on which phase of the development of the dispersal of the technology that you're in. Zero marginal cost society is the impact on society as a whole, and it starts to look at the integration of power networks and data networks. For example, in Europe at the moment, we are using data centers in modular containers to provide heat into district heating systems. Thank you for being late. Now that's a great book just to talk about the tornado effect of these technologies. Open for Realists, another very good broad-based book. And the book in the middle at the bottom, The Public Cloud Revolution, How Open Source is Displacing Proprietary IT Amongst Mega Vendors. That is a book. It's not available as a hard book. It's an e-book. You can download it for $2 from Amazon. And that tells you what's happened over the last few years. Lots of people are just not aware of this revolution that's happened in open source hardware, and that book gives a very, very good study of why it's happened, how big it is, and the impact on all the traditional vendors, the vendors like Oracle, Cisco, HP, Dell. And the last book is called The Inevitable, and it's about revolutions in technology and certain things that are inevitable as we move forward in time. So what is the Open Compute Project? The best way to explain this is probably to give you a very short video, and it will give you the history and how it all fits together.
So you've heard about the Open Compute Project, but what exactly is it, and how do you get involved? Let's rewind. In 2009, a few engineers, hey guys, at a company, hey Facebook, realized in order to accommodate their huge influx of data, they'd have to rethink their infrastructure. So they set out to build the world's most efficient data center. They did, but it got them thinking, if open source collaboration could create a software revolution, couldn't it do the same for hardware? So Facebook shared their knowledge with the world, and with the help of Intel, Microsoft, Rackspace, Goldman Sachs, and Andy Bechtolsheim, the Open Compute Project was born. Today, OCP is a thriving global community with hundreds of member companies and thousands of engineers collaborating to break open the black box of proprietary IT infrastructure to achieve greater choice, customization, and cost savings. Our project communities are led by volunteer leaders and overseen by our incubation committee to guide initiatives in data center facility, hardware management, high-performance computing, networking, open system firmware, rack and power, security, server, storage, and telco. The result? Member organizations and solution providers collaborating to create embedded software, firmware, hardware, and facility guidelines based on OCP's tenets of efficiency, scale, openness, and impact, improving the efficiency of data flowing from the edge to the cloud worldwide. So, can open source collaboration create a hardware revolution? It already is. Join us at opencompute.org.
Well, there's a brief introductory video. The Open Compute Project Foundation is a not-for-profit open source hardware foundation, as I say, started in 2011. And in the last decade, it's grown to enormous proportions. A very large percentage of servers made today going into data centers are OCP hardware. You can look on the Open Compute Project website, go to Marketplace, and you'll see nearly 200 products. Servers, switches, storage devices, racks, whole data centers. We also have designed open source data centers. And if you wish, you can just download the specifications and build them yourself in your bedroom if you wish, or your garage. So it's completely open. Now, something that's probably not happening in South America yet, but it's really big here in Europe, is public sector are specifying open source policy in European countries. And I'm just going to quickly play you this short video produced by the European Union, and it will explain why they're doing it.
Imagine for a moment our government would treat our public infrastructure, like our streets and public buildings, the same way it treats our digital infrastructure. Our members of parliament would work in a rented space where they weren't allowed to vote in favour of stricter environmental laws because the owner, a multinational corporation, didn't allow that kind of voting in its buildings. Nor will it allow a long overdue upgrade to more than 500 seats. This means some members of parliament have to stay outside in the street. And a couple of blocks away, a brand new gym is already being torn down just 6 months after it was built. It's being replaced with an exact replica at great expense. And the only difference, the new manufacturer also provides streetball as an added feature. Meanwhile, every night through a hidden back door in the city hall, documents that contain sensitive information on citizens, from bank data to healthcare records, are being stolen. But no one is allowed to do anything about it, because searching for back doors and locking them would infringe the signed user agreement. And as absurd as this sounds, when it comes to our digital infrastructure, things like the software and programs that our governments are using every day, this comparison is pretty accurate. Because mostly our administrations procure proprietary software. This means a lot of money goes into licenses that last for a limited amount of time and restrict our rights. We aren't allowed to use our infrastructure in a reasonable way. And because the source code of proprietary software is usually a business secret, Finding security holes or deliberately installed backdoors is extremely difficult and even illegal. But our public administrations can do better. If all publicly financed software were to be free and open source, we could use and share our infrastructure for anything and for as long as we wanted. We could upgrade it, repair it, and remodel it in any way to fit our needs. And because the open source in free software means that the blueprint is openly readable for everyone, this makes it much easier to find and close security holes. And if something practical and reliable was created digitally, not only can you reuse the blueprint all over your country, but the actual thing itself can be deployed anywhere, even internationally. A great example of this is Fix My Street. Originally developed in Great Britain as a free software app to report, view, and discuss local problems like potholes, it's now being used all over the world. Everyone benefits because new features and improvements are shared by everyone. If all our software were developed like this, we could stop struggling with restrictive licenses and could start thinking about where and how software could help us. We could concentrate on creating a better society for everyone. So, if you think that tomorrow's infrastructure should be in our own hands, help us now by sharing this video and visiting our website, publiccode.eu. It's time to make our demand. Public money, public code.
Now, as you can see, a lot of this is all about breaking the chains of proprietary vendor lock-in. The costs to government IT projects have been enormous because they have been locked in to contracts, proprietary hardware, proprietary software. On that presentation, that video, it spoke about code, just software. And in some European countries, back in 2014, legislation was passed that all publicly financed projects must include open source software if it's available. The move today is towards open source software and open source hardware, and some governments already in the European Union are running ahead of the pack. And before the EU Commission push for hardware and software in all member states, they are specifying open source hardware and open source software on their government clouds, their G clouds. This is creating quite a shake-up in the whole industry in Europe. Now, one thing that happens in open source communities, everything is reinvented. And the Open Compute project, when it was started by the big consumers of hardware, Goldman Sachs, Microsoft. And you could argue that perhaps in the beginning it was like a big buyers club. The consumers that wanted to get involved and design their own hardware, becoming prosumers that wanted to get actively involved on the design, had so much economic power that they could move the supplier vendor market to satisfy their requirements, because these big prosumers consume huge amounts of hardware. And if you wanted to see some of these prosumers, if you go to the Open Compute project website and look on the membership database, you will find all of the biggest hyperscalers in the world. Not just the North American ones, you will also find the Chinese hyperscalers. And one thing that's not obvious to a lot of people is just how big the Chinese hyperscalers are. For example, about 2 months ago, Tencent, which is one of the big Chinese hyperscalers, and by the way, not as big as Alibaba, made a commitment that they will be investing $70 billion on new infrastructure in the next few years. And last week, Tencent made an announcement that they were building a single data center that had capacity for 1 million servers. So watch out for China. Now, this here is Larry Ellison. Larry Ellison was the founder and the chief guy in Oracle. And he once said, once open source gets good enough, competing with it will be insane. Now, what happened in the last decade, open source technology really did get good enough. And companies are falling over themselves at the moment to adopt this technology in their infrastructures today. This decade there's a huge growth in the adoption, and we have this kind of ridiculous situation in Europe where we have a huge demand for the technology, but the supply channel isn't big enough to cope with the demand. So this is something you will see in South America and in Mexico. It might be slow to take off. You might hear me talking about open source hardware now. And with all major changes, it happens in a kind of a two-phase way. It starts gradually, and then it accelerates suddenly. So let's have a look at reinventing virtualization using open source software. What's the impact? Here we have an image of 10 physical servers. This was pre-2008. In pre-2008, there wasn't any virtualization. And then VMware came along. We got what was called heavyweight virtualization. Now, what virtualization does, it optimizes the workgroup potential, the amount of work that a physical server can do. So when VMware came out and the banks and the big players were starting to implement VMware virtualization, we started to see a drop of about 33% less servers in a data center of a big bank because of this. Now, what happened? The open source community started to develop virtualization, and you may have heard something called Linux containers and Kubernetes, which orchestrates these instances, these Linux containers, and moves them around the hardware. Well, the impact is that since 2008, using the open source lightweight virtualization, you could run on 2 servers, or 20% of the server count. If you're starting with 100 servers, it would be 20 servers, but there's actually an 80% less hardware required to do the same workload. Now, this is really what cloud is about. It's about the virtualization of everything. And I would recommend that you kind of study this, because everybody keeps talking about the growth in hardware, but in reality, that's not truly a global reality. This is another example of open source software eating web servers. Now here we've got servers, physical server nodes. This was a case study from Facebook. And because they were trying to grow so fast to get their users into their network, and I'm talking about, huge numbers, billions, they just couldn't extend and grow their infrastructure fast enough, their data centers. So they gave the problem to some software engineers to utilize the hardware more efficiently. And the first thing they did, they developed a new open source programming language called Hack. And then using Hack, they developed something called a hip-hop virtual machine. Now, the impact of this hip-hop virtual machine was it reduced the amount of physical server nodes that Facebook needed by 80%. This is what's enabling the hyperscalers to grow so fast, to scale so quickly. It's software combined with the hardware. And just in case you don't know, that all of Facebook's infrastructure is based on open source software and also open source hardware. And if you go into YouTube, you will find numerous videos showing Facebook hardware, OCP hardware. and they are huge consumers of this technology. Now, the next thing we needed to do is reinvent the server. Now here I have a server. I'm looking at the back of a server, a traditional proprietary server. And I will ask a question: why are all the cables on the back of the server? Why do we have all the cables on the back? Because when that server is in a data center rack, in a cabinet, you have to be standing at the back of the rack in all that heat, boiling away, cooking, while you're messing about with the cables on the back. Now, the reason all the cables are on the back is because what a proprietary server really is, it's no more than a desktop PC that someone put on a shelf and pushed into a rack. And the proprietary servers really haven't changed since the day of the desktop PC. They've changed their shape slightly, but they're fundamentally the same. And the cables are on the back, because if all the cables are on the front, then all the cables would spill over the front of the desks and tangle with your legs. So the cables are on the back to fall off the back of the table. Now, I'll just show you what we've eliminated when we reinvented the server way back in 2000 and, well, just over 10 years ago now. So let's have a look. On the left-hand side, we've got the AC to DC power supplies here. So there are no AC to DC power supplies in an OCP server. We took them out. So let's just take out. So those two AC to DC power supplies have disappeared. We don't have them. Now you can imagine this is going to have a substantial impact on cost. But it also has a substantial impact on energy performance, because if you're running two power supplies in what we call a 2N mode, you can never utilize either of the power supplies by more than 40%, because when one fouls, the other one has to take the full load. So these power supplies are running never higher in the 2N mode, more than about 40% utilization. And at 40% utilization, they're not very efficient. You get lots of heat loss from them. So that's a big deal. You know, we're trying to save energy, reduce costs. And we've got this crazy situation that every single traditional proprietary piece of gear, switches, servers, have all got 2N configured power supply units. And there's this other thing that's a problem, that none of the power supply units are compatible with any other equipment, even within the same manufacturer's products. So we call this gratuitous product differentiation. Now let's just walk through this and throw a few more things away. At the back you've got all these slots. And then we have here the status lights on the back. We have the 4 operational Ethernet ports. We have the out-of-band management port. We have another management port, which is Ethernet. We have the USB ports. There's 2 on this one. Number 13 is the video port. And then we have more slots. Now, fundamentally, what we've done away with all that, because on an OCP server, which I'll show you in a minute, the only thing on the back is a DC, a direct current clip, so that when you push the server into the rack, it just clips onto a 12 volt or a 48 volt DC busbar. You never go to the back of an OCP rack to do maintenance. Everything is done from the front. So that's what I mean about reinvention. And here we are with 2, we call them OCP toolless vanity free cubby servers. Now they're vanity free because there's no bezels on them. There's no video cards in them because you never used them. And all the crap that was there all the dross that was there when it was a desktop PC have been removed because they're not required anymore, because now we've got a data center server and not a desktop PC that's been bastardized to fit into a data center. Now on the left here, you can see these green things, and these green things are called green touch points. Now on an OCP server, all the maintenance is toolless, and the way you remove things, you just touch these green touch points and you remove components with these green touch points. Now it's so fast that you can replace any component in one of these servers in less than 180 seconds. And you can replace about 80% of those components in less than 60 seconds. Now, if you were looking at a traditional proprietary server, it would take you minutes just to get the covers off, to get the screws out, which you'll probably lose, using tools that you will probably find will drop into the server rack, cause issues, or you'll lose them. This is all toolless. So what I'm showing here, I'm showing a cubby server with a green cover on, and then I'm taking the green cover off. That cover is an air guide. And there you see the two CPUs inside. Now, these servers are deeper than traditional servers. And at the back of this server, you will see these two big fans. These two fans are 80mm fans. These CPUs have very big heat sinks on them. Now, the bigger the heatsink you can put onto a CPU, the easier it is to get the heat off. Now, the problem with the traditional proprietary servers, what we call pizza box servers, is they're so squashed, like a pizza box, that it's very, very difficult to get the heat off of the CPUs. So there's very elaborate cooling mechanisms inside just to try and get the heat off. In the back of the traditional servers, you will find a big array of fans. Now let me start talking about fans. So here's the 40mm fans that you will get in a traditional pizza box server, and there would be roughly 8 fans normally, plus the fans inside the power supply units. You can't put larger fans in because the pizza box isn't big enough. You've got to fit all this into one EIAU space. Now, what the Open Compute project, we call them makers or hackers, did, they said this was silly to do this, have all these fans. Let's change the physical shape of the server, design a new server board, a motherboard, so we can put 80mm fans in. So when you go to an OCP rack, you will find 3 of these cubby servers side by side. Now, let me just explain something called the fan cube law. Now, what the fan cube law is this, and it's something that I learned when I was in school when I was 16. And it's the physics of fans. Now, if you reduce the speed of a fan by 50%, so if you halve the speed of the fan, the energy required to spin that fan reduces by 7/8. So just let me say that again. It's just a basic fan law called the fan cube law. If you reduce the speed of the fan by 50%, you reduce the energy required to spin that fan by 7/8. So if we looked at the 2 fans on the bottom compared to the smaller fans on the top, the 2 fans on the bottom, which are pulling the air through the server, like the ones at the top, are using about 1/10 of the energy of the tiny little whizzy fans at the top. Very simple thing to do, and all they've done is reinvented the shape of the server to get the gains on the fan cube law by using bigger fans. Big fans are much more efficient than tiny whizzy fans. They also reinvented the rack. Now, there's a video I'm going to show you in a minute on how the rack works. But before I go on to that, I'm just going to explode this conventional rack, and I'll walk you through what it is. This is a conventional server rack. The blue horizontal lines at the top are Ethernet switches. The red boxes attached to each are 2 AC to DC power supplies. The grey horizontal lines are the servers, the pizza box servers. Again, they've got 2 AC to DC power supplies on the back. The little orange circles, they're the 40mm fans inside the servers. On the back of the rack, you've got these green vertical strips. What they are, they're the $1,000 IEC intelligent power strips. Also in the back of the rack, you've got all the cable spaghetti. Then you've got the hot air comes out the back, it goes over the top and it goes down into what we call a downflow crack unit, a computer room air conditioning unit. Uses mechanical chilling and refrigeration, passes the cool air under the floor and then back up to the front. Now what I'm going to do, I'm going to rip this down and turn it into an OCP rack. I'm just going to click through. So first thing that goes, start looking at those little orange circles. They all go. Next thing that goes is all those AC to DC power supplies, because we don't have them inside the servers or the switches anymore. Next thing that goes are the Ethernet switches at the top of the rack there. Now, I don't have time to go into this detail, but the management is all done differently in an OCP rack, and it's done very cost effectively using a $25 Raspberry Pi. A Raspberry Pi is what children use in school. It's an open source computer. It's as big as a matchbox, and that's what's used instead of these switches. So I've thrown away several $1,000s worth of Ethernet switches and I've replaced it with a $25 Raspberry Pi. Let's keep clicking. So these $1,000 IEC power strips, we throw them away because we don't use them anymore, because all we have in the back is a DC bus bar. We don't use the downflow crack units because we don't have mechanical chilling anymore. We don't need it. Therefore, we don't have the air passing under the access floor. This dotted line on the bottom is an access floor. We can take the access floor away because we don't use the access floor. You can put these OCP racks on an access floor, but why do it when you don't need it? We throw away all the cable spaghetti in the back. Now what we've done, we've thrown away all this stuff. Now just to kind of put this into perspective, this cost that I've thrown away, now this is just in a single 40 server rack. I've thrown away 2 top of rack switches, the pluggable optics on the fiber links, 86 power supply units, 208 40mm fans, 4 AC power strips, 86 IEC rear power cords, 120 RJ45 rear patch cords, crack units, access floor, and all the cables in the floor. Now that equates, depending on how it was configured, somewhere between $10,000 to $16,000 saved per equipment rack in the data center. I'll just repeat that. It's $10,000 to $16,000 savings per equipment rack. Now I'll just quickly take you through this. This is the rack. On the left there you can see that photograph, and in the back you'll see that vertical strip. That's the direct current bus bar. Here we have the buzz bars going in the back. You can configure them different ways. You can put 3 in the back if you wish. These are the different types of connectors that go on the back of the servers to clip onto the buzz bars. And then we use these rectifier shelves up to 18 kilowatts on a single U. Now this provides the DC feed from the 3-phase AC into the buzz bar. So it's very, very simple. And that's why we don't need all the AC to DC power supplies inside the servers and equipment. Very simple. This is the thing, there's an obsession with simplicity with open compute technologies. Very simple. Now, we also reinvented the data center. Let me show you. Here we have a traditional data center. This is typically what you'll see. You'll see all the cooling systems, the chillers, the chilled water pumps, the condenser pumps, the cooling towers, water booster pumps, water treatment works. Then on the top, you'll see the centralized UPS, the IT load at the top there. In the dark green racks is the white space. And then we'll have the crack units, the downflow crack units. Now that's typically how you would see a traditional data center. Now what I'm going to do, I'm going to gradually click through and I'm going to take out things that we don't use in OCP data centers. So first thing we take out all these chillers because we don't need any mechanical chilling. You might be asking, why don't we need mechanical chilling? Well, we don't. OCP servers are much, much higher ingress temperatures than traditional proprietary servers. Much higher. Some of these like 55 degrees on the intake. Now lots of people have got traditional data centers might be running the air intake temperatures on the front of the racks at say 22 degrees. That's why you need all the chillers. And the chillers account for a very, very large amount of the overhead of the facility. We take them out. And then we take out the centralized UPS. We don't use the centralized UPS. We do it differently. So what we do, in the IT racks, we embed lithium-ion battery backup units in the IT load racks to do the UPS function. Now here it still shows generators. Now I've not taken those out, but we are building OCP data centers in Scandinavia, in the Nordic regions, Sweden, etc., where we don't even have standby generators. That's another story. But you can imagine how much this reduces the cost of the installation. Now, what does it do to the cost of building the data center facility? It does this. So a traditional uptime tier 3 might cost you $8 million per megawatt of IT load. Now in Scandinavia at the moment, we're building OCP data centers at $2 million per megawatt. So you can build four OCP data centers at the cost that used to build a traditional uptime tier 3. Now let's look at operational cost comparison. Hardware server technicians. There's the hardware server technician. In a traditional data center, he might be able to support up to 400 servers. But often you'll find in small data centers, you'll have one technician for just 50 servers. Now if we look on the other side, in OCP data centers, you just need one server hardware technician to support 48,000 physical server nodes. Now that's more than a 99% reduction in people needed to support the data center. Now I'll just show you this, which is a video of a data center up in Sweden. And I'm trying to show you this because I want to get across how quick it is to install OCP gear inside the data center. You don't unpack the servers in the data center. They're all manufactured off site. They're all put into the rack and then you just wheel the racks in. And the installation time for the servers at the data center is about 250 times faster than the conventional proprietary unpack, rack and stack. Now this is actually going to walk you through how simple it is. So as you can see, it's relatively simple. Now, reinventing the network, the 0 copper permanent link cables. The reason the copper permanent link cables are finished is because the speeds that we run networks in OCP data centers are like 100 gigabit going upwards. Copper is dead. Now, I'm not going to run this video, but look at this video and it will show you the amount of business there is for the BICSI members on doing the fiber optic infrastructures within these OCP data centers. So don't cry the fact that you've lost all of your copper cabling, because there's a huge opportunity on fiber if you know how to do it. It's fiber, but it's not traditional fiber. And there's a chap in England who's an expert on this called Mark Dancy, and perhaps we can do another seminar just on the opportunities. Now, this technology was used by the hyperscalers, but now it's been adopted by the telecommunications people. So, and why are they doing it? I'm going to show you a very quick 30-second video and you'll see the magic of OCP.
This is an actual photo of one of our data centers. This one is in Atlanta. On the left-hand side, you see the traditional legacy CDs. You see all those cable, those analog connectors and all the analog combiners and all back here at about 8 amps worth, reading about 192, so let's go 492 nodes. And then on the right-hand side, you see the VCMPS. So anyone wants to know what virtualized? Any other questions?
Now, it's been a kind of a silent revolution, a hidden open source revolution that's occurred. And this was actually a slide done by a Dutch data center consultant after he discovered OCP in 2016. It just blew his hat off that it was just so much better than all the other approaches. Now, what I'd like to do is I've taken you through a few new things. Might have killed some babies, perhaps, because what I'm really saying, it's the end of the traditional data centers, the very expensive, not very energy efficient data centers, lots of people required. At the end of the day, the technology that wins is the one that's good enough with the lowest cost. And it's not just financial cost, it's environmental cost as well, and social cost. So you don't have to sack your people. The fact you don't need so many hardware server technicians, you can retrain them, because this is all about open source software and open source technologies. So I would like to leave you here depressed, because if I leave you here depressed, then the only way is up. Some people can't get past the denial stage, and they're the companies that are going broke with the impact of this technology. So hopefully I've taken you to depressed, and you can move to acceptance and integration and make a good living from this technology, which is coming to South America this year. And now for any questions.